So the first thing that we're going to do, I'll let you have one of these. I'll let you have one of these. The first thing we're going to do is we're going to review the factoring that we've already learned this year. Want to make sure you're good there. So we learned about how to factor already this year. We learned about the GCF method. Okay, so let's start with that. Let's factor that. I want to factor that. So the GCF method is the one where you look for numbers that divide into these. So what's the biggest number that goes into 5 and 25? 5. And then you can also take out some x's, right? So we can take out an x also, right? And then what we're going to do is we're going to divide that out of these. So what's 5 divided by 5 give me? 1. And what's x squared over x? Right? It's just like if you have 2 and you're taking 1 away from it, basically, right?
So it's
Minus 5, yeah. And here, x take away x, you're just going to have no x's left at all. And so that's your GCF method. All right? Let's see how you guys do. Just want to make sure you guys are, we'll call this our example 1 here. Let's do a practice problem just to make sure you guys are good. You guys go ahead and fact that, see what you get. Adrian Hernandez. What did you put out here, sir? Okay, good. So we found the GCF correctly. 2 goes into both of those. And you took out x squared. Took out 2x. Okay? All right. Moving onwards, we have John. What did you get in these spots, John? John? Is John Chavez? Hello, sir. Huh? You didn't do it? Can you put your phone away then? All right. Adrian Canizales. What goes here? Good. So this one's a little bit tough. Some of you guys probably left it as 0 or maybe just nothing. But you got to understand, you're dividing this into these. And when you divide something by itself, it should be 1. Okay? So there's your GCF method. Let's proceed onwards here. There you go. So that's one of the factoring methods we've already talked about this year. We're going to review the other 2. We've learned 2 others. One of them will look pretty familiar, I think, from yesterday. Okay. So let's try a second one. How about the difference of squares method, like 4x squared minus 9? So what we learned about these ones is that whenever you have 2 numbers that are perfect square roots, like you could take the square root of them and get a pretty nice number, right? What's going to happen is you're going to take the square root of this. What's the square root of 4x squared?
2x.
And the square root of that? It's like the opposite of what we did yesterday, right? Working backwards. Yesterday we started like this, and you square these. Today we're working backwards. We take the square root and break it up. So that's the difference of squares method. I imagine you guys are probably okay-ish with that one. I'm not sure we really need to practice one of those right now. I mean, we can if you want. Does anybody want to practice one of those?
Well, what?
Do you want to do that?
Yeah, the practice.
Okay, thank you for asking. Because I would have just kept going. All right, how about we do 25x squared minus 36?
This
Well,
is a student practice.
Yeah, this will be a student practice too. See if you guys can factor that one. Okay, John.
Sorry.
Yep. How'd it go? What do you think of that email?
It's very truthful.
There we go.
I appreciate the fact that you have that practice. Sometimes I'm on my phone. It's
You
very
know, but I was honest because I don't feel like you are distracted.
good. Because I probably would have lost my phone. Talking about my phone.
Hey.
Thank you.
Go ahead, Hannah. What do we get for this one?
Progress
Uh-huh.
on both sides.
Good.
Minus plus
There you go. Nice job. So that's another factoring strategy we've learned. Let's go ahead and take a look at the last one. The last one's the really sucky one. It's the one that's kind of a pain in the butt. Here you go. Example 3.
Wait.
It's the one with 3 terms.
Oh,
Two
my God.
Okay, don't write this yet because I gotta think about it before I.
The box one?
Oh, this will work. Yeah, it's the box one. Yeah. So, huh?
Is that a sign?
Are you making fun of my writing, bro?
I'm just asking.
What else would it be?
An arrow. 'Cause right now
An
it's like-
arrow.
it
Have you ever
looks
seen an
like
arrow in the middle of
arrow.
an equation? You know it's a 7 and you're being mean. Yeah, it's a 7. All right, here we go.
Wait, that doesn't look like an arrow.
Mouthy.
For what?
Here we go. So here's how the box method works. First term, top left. Last term, bottom right. Correct? Now we find the numbers that work. So what times what makes 2x squared?
2 and x squared. Oh, 2x and x.
What times what makes 5?
1 and 5.
Okay, so where should I put the 1 and where should I put the 5? Any thoughts?
The one on top and the bottom.
If we're wrong, it doesn't work, and I'll tell you how we know it works in a minute, but if it doesn't work, you just swap them. And if that doesn't work, that means maybe it wasn't the numbers we chose in the first place. But in this case, it has to be these numbers because those are the only possible numbers they could be. There's only one way to get 2. There's only one way to get 5. So, all right. So 2x times 1 is 2x, and 5 times x is 5x. Now, how do we know if it works? Is there any way these two numbers could be combined to give me -7?
Only if they're both negative.
If they're both negative. So that means,
You have to make 5 and 1 negative.
go ahead and make those a negative. But that would only happen if these were negative to begin with. And so, there you have it.
And you'd still get positive 5.
That's right, because negative times negative is positive. All right, so I'll throw one of these at you. Thank you, ma'am. Student practice 3. X squared minus 5x plus 6. Go ahead. So, Chris Jones. What goes here?
X squared.
And Chris Jones, what goes here? So true. So, how's about, not Eric, but let's talk to Augustine. What goes here, Augustine? True. Very true. Let's try David. What goes here, David? It's even got the signs. Let's see if that works. X times -2 is -2x. -3 times x is -3x. Okay. Do these combine to make what we want? Yes, they do. And so our answer is x minus 2, x minus 3.
Oh.
Okay. So,
Why does your 3 look like an X?
why does my 3?
It's included like this. Like where you put X, 2, 3.
Oh, yeah, he had trouble finishing this direction. There we go. So, now we're going to learn something new. You ready? Something new. Example 4. Ready? No, I keep asking. I'm going to do it anyway. All All right, 2x cubed plus 6x squared plus 3x plus 9. So what's different about this one is it has
Really big.
4 terms.
So we're gonna
Wait.
do something kind of like the same, right?
We can do the box one. Thank you.
We're going to do the box
The
method.
3 box.
Damn. Dang
Or,
it.
no, I think it's gonna be
Darn it.
Mr. Bailey. It's gonna be a 3x2 box, right? It's only 4 numbers.
No, you're thinking of multiplying. Here, I'll show you what we're going to do. Check it out. Ready?
It's still gonna be a tiny box.
What number am I going to put here?
2x cubed.
Yes. What number am I going to put here?
9.
The other 2 numbers go in the other 2 spaces, and it really doesn't matter where you put them. You'll get the same answer either way. Okay? So, here's the deal. You could guess and check, but I have a way you guys can actually just get the answer right away without guessing and checking. Okay? Now, you could guess and check. You could be like, okay, 2x squared and x if you wanted to. But you might end up with wrong answers that way, and I have a way that's going to help you not do that. Here's how you do it. Let's start here. Let's look at these two together. What is their greatest common factor?
2x squared.
That's what goes there then. No guessing. That's what goes there. Now, we couldn't do that with the other one, right? Because with the other one, we only had the top left and bottom right, so we couldn't do that. But here, since the whole box is filled in, what do these two have in common?
3.
So that has to be a 3.
Oh, okay. So you didn't get
How about upwards now?
x.
And how about upwards?
X squared. No, 2x squared.
No squared because the 9 has no x's to give. Just a 3. Now,
2x squared plus 3, and then it's x plus 3.
yeah. So here's a couple of notes for you guys. So that is the answer. But here's a couple of things I want you guys to be aware of. First of all, if they're both negative, then take a negative out, okay? If they're both negative, then take out a negative. So like if these were both negative, you'd take a negative out, okay? What else? The other thing that could happen is you could end up with 2 terms that don't have anything in common. Like say, for instance, you had this. These have nothing in common, right? So when that happens, you don't just skip it, because they actually do have something in common. There is something that divides into both of those. You would put a 1 there, okay? So if they don't have anything else, just put a 1. They should always have that. And another thing is, with this box method, I'm only going to really be giving you ones that it works for, but technically, the box method could fail with certain 4-term polynomials, technically. So really what you're supposed to do is after you get all this figured out, is you want to go back through and multiply just to make sure everything actually does work. If it actually works, then you're in good shape. If it doesn't, that means it's not factorable using this strategy. All right, so there's your 2 things I want you to be aware of. If there's a negative, factor it out, and also if they have nothing in common, take out a 1, okay? So let me throw one at you guys now, student practice. You guys try this one, x squared plus 5x minus 3x minus 15. Go ahead.
No, if I...
Now, some of you guys might have set this up a little bit differently, but what everybody has to have is this, x cubed in the top left, negative 15 in the bottom right. Some of you guys might have put your negative 3x here, some of you guys might have put it here, but it really doesn't matter. You're still going to get the same answer. So, without looking at your paper, because your paper might be different, you know, just look up here, see if you can tell me the answer. So, Gabriella, what can I take out of this row? Cool. And how's about Henry? What can I take out of this row?
5.
Cool.
Wait. Negative.
No.
Oh, 100?
Yeah.
Oh.
Kayla, what can I take out of this column? And then finally, Natalie, what can we take out of this column? Yeah. And so the answer would be x squared minus 3 times x plus 5. Okay? So,
That's it. So we're waiting
No. No. This is too easy. I haven't done my job until I have a student leave my room crying. That's my goal every day. Yeah. I mean, if you guys push a cry, I can stop.
If I cry, you'll
I need tears right now.
Don't trust me.
I drink tears. Okay. That's
Oh, yeah.
fine. Okay. No, by the way, I just thought of something, by the way. I realized it's possible. It's possible.
Someone make me cry.
It's possible that if you have a positive number here, but both of these are negative, would you have any rows that have both negatives in it? Would you have any columns that have both negatives in it?
No.
No. And so everything you have would be positive on the outside, right? But you need negatives on the inside, don't you? So that's another situation. If you ever have a positive here and negative in both spots, what's going to happen is both of these are going to be negative, because that's the only way you can get a positive there with a negative present, just so you guys know. Okay? All right. So there's that. Now we're going to go on to one more thing. The problems I'm going to give you right now are a little bit intense. The good news is, you guys ready for some good news? Even though these are a little bit intense, you don't have homework tonight.
Oh, really?
Yes.
Wait.
But tomorrow we're going to work on your homework in class, because I feel like you'll want some more help with it. And then whatever you don't finish in class, you can take home. Okay? So here we go. Let's do example. What am I on now? 5. All right, here we go. Actually, before I do example 5, I would like you guys to write down this chart. Actually, before you write down the chart,
Wait, why are we doing?
I think this is you're just gonna test our patience until we get.
no, I'm not. I'm actually just I'm just
Trying to
off my game. So check it out. Let's factor this 6. What? Don't write this. Just watch. What does 6 factor into? Okay, good. And we're done, right? But what if I asked you guys to factor 12? 6 and 2, but we're not done, right? Because the 6 can be factored again. The same thing applies to polynomials. Every problem we've done so far, we factored once, we were done. But who's to say that those pieces that we break it up into can't be factored again?
What?
So that's the kinds of problems we're going to be looking at now. Doesn't go up there again? Oh, okay. All right, so here's what we're going to do. I'm going to give you a little bit more of a complete factoring strategy now. How to factor. You can start writing this now. Polynomials completely. How to factor polynomials completely.
Wait, so you did not want to write this because you were factoring down to 64.
And you could just write yours on a. I can't print out the answer sheet right now, so just write your answers in a separate sheet. Okay, so here's how you factor polynomials completely. In other words, not just once, but maybe a few times. Sure. The first thing you do is you always start by looking for a greatest common factor. It may be there, it may not, but you always start by looking for a GCF.
But is there gonna be people in here?
Yes, there usually is. Now, at that point, if you have 2 terms, it's probably a difference of squares. Yeah, you guys should be writing this. It's probably a difference of squares. Okay? If you have 3 or 4 terms, it's going to be a box problem. Okay? And you just keep doing that until you get to the very end and you can't factor anymore. Okay? Keep factoring until you can't factor anymore. Okay, so review. How to factor polynomials, take out a GCF. Then if it has two terms, do a difference of squares. If it has 3 or 4, do a box. Keep going until you can't go anymore. Let's do one. Ready? We have 8x cubed plus 6x squared minus 8x minus 6. And what did we say to do first?
Box.
Nope. Always do your GCF first. So here we go. Ready? What goes into 8, 6, 8, and 6? Can I take out any x's? Nope. So I'm going to divide all those by 2. Pay attention. Pay attention. All right. Now, let's take a look at what's left. Does that have 2 terms, 3 terms, or 4 terms?
4 terms.
And when there's 4 terms, what method do we use? The backs. The backs. That's how you say it when you're from the Bronx. You put the numbers in the box. Then you factor them out. You put your answers at the top.
I think you forgot the X.
Okay, genius. Thank you so much. You're so smart. Holy smokes. Just kidding. I appreciate you. All right. So what can I factor out of these two?
X squared. Wait, whoa.
2.
2 and an x. How about these two?
3.
How about
Wait, so does it matter how we set this one up?
Just X.
X squared.
same rules as last time?
We set this one up and wait, yeah.
X squared.
How about these guys?
-1. Wait.
-1.
Oh,
Oh,
I was right.
Okay, now don't forget about this guy. Don't leave him behind. He's one of our factors, okay? So right now I've got 2, and I've just factored that thing apart into 2x plus 3 and x squared minus 1. Now, who says I'm done? I may not be, right? You already see it. But before I let Kayla tell us what it is, these have 2 terms. What factoring strategy works for 2 terms? The difference of squares. Which of these is a difference of squares? Is this a difference of squares? No, it's not minus, and these are not perfect squares. So guess what? That one's done. How about this guy? Is this a difference of squares? Yes, it is. This is a difference. It's minus, and these are both perfect squares. So let's do it. If I wanted to factor that, what would it factor into?
Oh, X.
There you go. Now, let's keep, who says we're done?
You thought.
We've already said these are done. How about this? Is this a difference of squares?
Yeah, because there's a
No. Is this a difference of squares?
Yeah.
Nope.
No.
You want to know why it's not?
Because it's not a square. Yeah.
Because that x is not a perfect square, so you can't do it. So we are done now. But you guys see how I had to factor multiple times to get this thing all the way down. And that's what I mean. So you always start with a GCF. Then based on how many terms there are, you're either going to do difference of squares or the box method. And you just keep going until you can't go anymore. The good news is box should only happen once in a problem. You shouldn't see that more than once usually.
Have you
I don't think so. All right. Now we're going to do a guided practice. That means you guys are going to do this with the work. So, here we go. Guided practice. GP. Here we go. Negative 3x 5 plus 6x cubed plus 24x. Okay. So first of all, I'm going to ask Kiana. What do we do first, Kiana? We find the GCF, okay? And you factor out the GCF. So I'm going to get you guys started. And I want to remind you of something, because you're probably going to forget if I don't remind you. When your number in front's negative, what do? probably been a while since I said that, but if your number in the front's negative, you need to take out a negative. So whatever your GCF is, make it a negative GCF. Okay? Anytime your number in front is negative, you can make your GCF negative. Go ahead, I'll pause so far. What'd you put out here?
Negative 3x squared.
I like negative 3x, but no square because the guy in the end can't afford a square.
Oh yeah.
All right. I don't know whose it is, but it's just been in my room.
Yeah, it's solely from being like,
Okay. I didn't know that.
and Noah was like attacking me for it. And I got a big ass hole in my side.
Heidi. Where are you? What goes here, Heidi? Not sure? Okay. Let's try Nathaniel. What'd you get here? Hannah. Right here. No.
X squared.
Okay.
Plus 2x to the second.
Plus,
2x to the second.
yes, but I'm going to say minus 2x to the second. Yeah, because we're dividing by a negative 3.
Minus 8.
And then, John, what'd you get at the end? Jonathan. What'd you get at the end? Close.
Negative 8.
Yeah. Okay. So, next question. Ready? Alexis, this thing has 3 terms in it. How do we factor something with 3 terms in it? You do the box. So I'm going to let you guys go ahead and do the box now. Go ahead and do your box.
How do I box between 3?
Put that in my bucket this time.
The way we've been doing the box when there's only 2. This one goes here. This one goes here. These 2 have to add up to make the middle.
Oh.
Put here. Okay, what'd you put here? And what'd you put here? And here? Here? Okay, let's see if that works. So let's fill in our box. This would be negative 4x squared. This would be 2x squared. And then we would combine these. If I combine these, do I get what I need there? I do. So we have x squared minus 4 and x squared plus 2. Okay, so Kendall, which, if any of these, are differences of squares? Kendall, which, if any of these, are differences of squares?
Can you repeat that?
Which, if any of these, are differences of squares?
Oh, that's a good question.
That's what they pay me for.
I'm gonna pass on this one though.
I think I saw Kayla for some reason. Kayla. Go ahead, Kayla. You're right. This one's not a difference of squares because it's a plus. So we get x something, and then the x squared plus 2 stays the same. So this is going to be x and what?
Oh.
And are these differences of squares now? No, so we're done. There's no more factoring that can be done. So that's another multi-step factoring problem. So we kind of walked through that one slowly. I do want to throw one problem at you gently, tossed really, laid gently upon your lap. And then you may pet it like a soft kitten.
I don't like cats.
I want you guys to factor this one. Giving you guys the easiest one.
That's not easy.
There's no box. No box. Easiest one. The process, okay?
Obviously, I'm right. I'm Jonathan.
Hey, I don't know about
The
that.
first thing that you do is you take out your GCF.
But how'd you get that?
That's what I'm showing you.
Oh.
So you take out your GCF. Then we have 2 terms. So the only thing that could be, if it's anything, is a difference of squares, which it is.
Oh, I did the whole box method.
Interesting.
Very interesting.
And then after that, it turns out we have another difference of squares right here. This one is not because it's plus. And when you factor this one, you end up with these two. So this one goes to these two, and then that one's there, and then that one's there. So
Okay, I feel retarded because I did the whole box and I didn't get the
interesting.
It still worked.
It could. You could do the box with
It
it.
still worked. It did work.
It's a little bit harder, but you could. So anyway, there it is. We're going to just practice factoring all day tomorrow. Give you guys lots of opportunity to get it drilled into your brains.
Good idea.
But that's it. So
Wait, it's a better piece of.
That's a slow idea.